In this video, we are going to discuss slope fields mostly. Let's start with our first one. Slope fields below are viewed in this window, -6, 6 by -2, 6. That's just our viewing window, how we're looking at the graphs. Which of the slope fields would be generated by the differential equation dy dx equals 3 minus y? So each one of these little slash marks on these graphs represent the tangent line to the particular equation of this differential equation. So like if we would integrate this, separate the variables, integrate, all that fun stuff, and solve for y, then this would help us look at what the tangent lines of that graph would look like. You don't have to do that though, because if you have the differential equation and the slope fields, you can just kind of match them up. It's a guess and check process. So you pick some points. You pick, as many points makes you feel comfortable so you can guarantee that the slope field matches the differential equation. So for example, let's say, and notice that we only have a y in this equation, so we can't pick specific ordered pairs, we just pick y coordinates. And that means that the y coordinate would have to be for every value of that y. So for example, let's say we pick y equals 3. I pick y equals 3 because when y equals 3, dy dx is 0, which means it's flat, horizontal tangent line. So that's easy to spot. So let's just say when y equals 3, for every value that y equals 3, for every single ordered pair where y equals 3, that would be like the ordered pair where x equals 1 and the y equals 3, 2, 3, 3, 3, 4, 3, 5, 3, all the negatives, every number in between. So it really just creates a row or a line of, in this case, horizontal tangents because the slope is 0 when y equals 3. So, okay, let's look at A. So let's say y equals 3 is like right here. And it looks pretty flat right there. So it looks like the slope could be, 0 right there. So this could be like the point 1, 3 and -1, 3. But check out when x equals 2, when x equals 3 and when x equals 4. The y coordinate is still 3, but the slope here is not 0. Here, 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 and the same thing goes this direction. So the slope needs to be flat for every y coordinate that is 3, and it's not. So this one's out. Let's look at B. Same thing. When y equals 3, which is right around here, we need to have a horizontal tangent line. So yeah, this is out too, because these are all different. This brings us to C and D. Notice they both look pretty similar actually. And when y equals 3, looks like it's approaching that horizontal line there. So I would be willing to say that it's going to be C or D because every coordinates on this graph where where y equals 3, looks like we have a horizontal tangent line here and on this one. So what happens is when you only have a y, notice there's no x, so this is true for every single x. When you only have a y as your variable, there's no x in the equation for the differential equation, it creates rows of parallel tangents. So I'll get into that more in a minute. Let's figure out which one it is between C and D. So we know that it's between these two because we have our horizontal tangent line when y equals 3. So let's pick one, pick another number for y. Let's just say y equals 0. That puts us on the x-axis. So for this one, notice that everything below the y equals 3 line right here, all the tangent lines are going down. So everything is negative down here. And everything above, all the tangent lines are going up. So dy dx is positive when y is greater than 3 for this graph, and dy dx is negative when y is less than 3. So let's check it out. If we pick a 0 for y, we get positive 3. If we pick a 1 for y, we get positive 2, meaning the slope of the tangent line should look like a slope of a 2. So this one's out because these are all negative and they should be positive. Means D is our answer. Because notice, when y is equal to 1, when y is 1, meaning that puts us right here on this line right here. When y is 1, the slope is approximately 2. That looks like it could be 2. When y is, let's say, 4 or 5, the slope has to be negative, which it is. So here's our answer. And let me go back to that rows of parallel tangents. Notice that when y is 5 or when y is 4, it's the same slope for every single value of y. So every single one of these has to be the same slope because it has to be the same for every value of y. So when you have just a y in the equation, it creates rows of parallel tangents. That's when you have y only instead of x's. Let's do the same problem again. Let's look at it in terms of x. So now you only have an x in the equation. It's going to create another pattern. So we can kind of eliminate C and D just because these ones have rows. These ones are going to be y only, both of these. So they're out because they create rows of parallel tangents. So we're between A and B now. So now for this one, if x is 3, for example, then we have a slope of 0, meaning horizontal tangent at x equals 3. So let's check out x equals 3 here. Looks like it's right around here. These should be horizontal tangent lines for the entire time that x equals 3, which it's not. It changes. These are all over. But for this one, I know it's not exact, but it is approaching. So it's going to be this one. And notice what happens. These are all columns. So we only have an x. When we only have an x, we have columns of parallel tangents. And I just remember this, that if you have x equals 3, it's a vertical line. So it helps you remember which one's vertical and which one's horizontal, because the y equals equations are rows, horizontal. Hopefully that makes some sense. Let's do some more examples. Okay, so we have a differential equation, dy dx equals x plus 1 over x. Notice there's no y's in this one. So we have 3 options. We have a slope field. This equation will give us a slope field with negative slopes in quadrant 1. We'll have a slope field with positive slopes in all quadrants. And then we'll have a slope field with columns of parallel tangents. Definitely 3. Just because there's no y in the equation, it's going to create a pattern where for every single x coordinate, or every single x value, it's going to be the same slope. So like when x equals 1, it's going to be x equals 1, y equals 1, x equals 1, y equals 2, x equals 1, y equals 3. All of them are going to have the same slope. So it's going to create a vertical line of parallel slopes. So 3 is definitely it. Let's check out the other 2 though, see which one of those might work, if there are any. And this is where guess and check kind of comes in. You just pick numbers. So if x equals 1, then you have 2 over 1. So when x equals 1, the slope is 2. And that's going to work for every single x equals 1. When x equals 1, it doesn't matter what the y coordinate is. It's the same for every single x coordinate, y equals 2. Okay, when x equals 2, you end up with 3 over 2. Another positive one. I know they're supposed to look the same. It's supposed to look different than x equals 1, but it's still positive. We're just looking at if it's positive or negative here. Okay, so when x equals 3, you end up with 4 over 3, still positive. When x equals 4, you end up with 5 over 4. When x equals 5, you end up with 6 over 5. Positive. This is positive. This is positive. So these slopes are going to stay positive in both of these quadrants. Let's go left. When x equals -1, -1 will give us 0 in the numerator. So you end up with flat. When x equals -1, that's when our dy dx equals 0. So take note, that is not positive or negative. 0 is neither. So we can rule out this one. It does not have negative slopes in quadrant 1. That's out. positive slopes in all quadrants. Tricky. Because notice what happens. If x equals -2, you end up with -2 plus 1 over -2. You end up with -1 over -2 that is positive. So you'd end up with 1/2 for this one. And that would be the same for every x coordinate when x equals 2. If you do -3, you end up with -2 over -3, positive number. If you pick -4, you end up with -3 over -4, positive number. They stay positive. So it actually is positive everywhere except for where x equals 1. So this is a close one, but it's not true because it's not positive when x equals 1. I'm sorry, when x equals -1. So this one's out. Tricky though. That could be one that is very tricky. So the only one that's true is 3, and that's because it has x only in the equation. Okay, let's do another one. Okay, this is another x only one. So it's not going to have rows, it's going to have columns. So this one's out. So now we have to look at producing a slope field with horizontal tangents at -1 and producing a slope field with vertical tangents at x equals 2. So horizontal tangent means that dy dx equals 0. So when x equals -1, you end up with 0. -1 plus 1 is 0 on the top. As long as you don't get 0 on the bottom, we're good, which we don't. You end up with 0 over -3. So this one's true. And then the middle one, 2, vertical tangents means that we're undefined, which is when we're dividing by 0. We have a number divided by 0. Notice that also happens when x equals 2, you end up with 3 over 0. So you're going to end up with vertical tangents there. So that one's also true. Okay, let's do one more. We have our differential equation, x squared over y. We have slope field with positive slopes in quadrant 1, negative slopes in quadrant 2, columns of parallel tangents. Well, we can say this one's out for sure because it has x and y in it. So it's not going to have any kind of rows or columns kind of pattern. So let's draw some pictures again. Think about plugging in numbers now. Okay, so we have x and y points. So if we go with the point 1, 1, then we're going to have 1 squared over 1. That's positive. If we go with the point 2, 1, we end up with 4 over 1. So that's also positive. It's really steep. Notice that it's always going to be positive in the first quadrant because this is always positive and then this is always positive. So this is all positive here. So that one's good. However, negative slopes in quadrant 2, that's not going to happen. So it would have happened if this was just x over y because you would have a negative x over a positive y, but we're going to have a negative x squared. So this will be positive always in quadrant 2, and this is positive in quadrant 2. So this one is also positive. This one's out. So the two answers here are 1 and 3. Oh, no, it's not. Sorry about that. No pattern. Okay, so just 1 on this one. Okay, last example. What type of function will the differential equation dy dx equal y produce? So this one you have to actually solve. So let's separate the variables. Multiply by dx, divide by y. That's a natural log. And and this is just a 1, so you end up with 1x here. And we undo this with the e again. You end up with all of this raised to the power of e. That's our fun little trick here of making that multiplication. You end up with c times e to the x. We don't have anything else here to plug numbers in. It's just asking what type of function, meaning like, is it quadratic? Is it logarithmic? Is it exponential? Is it a line, like of our 12 basic functions? In this case, it's an exponential function. So there you go.